Okay, so the book is asking us to find the total region between the curve and the x-axis, and it's not immediately clear to, it wasn't immediately clear to me, but I understand what they're saying now. So look, this graph looks something like this, okay? It's a parabola, goes down to -3. So some of that area is negative, some of that area is positive. When they say the total area, they mean they want you to have the absolute value of the negative area. So like if this is square footage, if it goes behind some sort of starting point, it goes in front of some form of starting point, you wouldn't want to have negative and positive square footage because you would add those together and it'd make it look like there's way less. So in other words, they want us to flip this so that this area is positive in here. So we really got to figure out where it crosses the x-axis. So to do that, we want to set our equation equal to 0 and solve. So you can add 3 to both sides, divide both sides by 3. So x is going to be positive or -1 when you take a square root of both sides. So -1 and +1 are where this graph crosses the x-axis. So we want to stop integrating there and then change the sign. Okay, we want to integrate from -2 to -1 of our function. But then we stopped at -1 because now we want to change the sign. So I can change a sign really easy by just multiplying the whole thing by -1. I want to go from -1 to +1 of our function. That will change the sign, right? Because this area we know is going to be negative, and so multiply by negative, that makes positive area. And then we're back to the positives when we go from 1 to 2. So we want to have plus there. Okay, so that's how we're going to find the total area, meaning we change the negative area to a positive area. So the antiderivative is going to be the same for all these. It's x to the third minus 3x. Because the antiderivative of 3x squared is x to the third. When you try to think of an antiderivative where x has a power, the power always goes up by 1, right? Instead of x squared, it's now going to be x to the third. And then it's just the coefficients you sometimes have to mess with. Okay. So the 3 would come down, multiply, then the power would get reduced by 1. Right. Then over here, it's the same antiderivative. Just, oh, sorry, I forgot my limits of integration here. And over here, same antiderivative. Just evaluate it from -1 to +1. And then over here, same antiderivative. We evaluate it from 1 to 2. Okay, so we got to plug in those limits of integration. If you plug in -2, that -2 to the third is -8. -3 times -2 makes 6, +6. Not sure why that took me so long to think about. Now that's the low. Wait, oh, I plugged in -2 first. I'm very sorry. So you're supposed to plug in the higher part first, the top part of the limits of integration. So you're supposed to plug in -1 first, and then subtract what happens when you plug in -2. So I'm going to put this in parentheses because I got to subtract the whole thing. -2 to the third is -8. -2 times -3 is 6. Okay, so that's what this one is. Sorry, I did do that in reverse at the beginning. I'm going to focus. I'm going to make sure I get this one right the first time. You plug in the upper part of your limits of integration. So plug in 1 in here. 1 to the third is 1. 1 minus 3 is -2. So that's what happens when I plug in 1. If I plug in -1, then I've got -1 to the third is -1. -1 plus 3 is +2 here. Wait a second, that shouldn't be... because there's between -1 and +1 should be negative area. Hold on. Plug in 1. 1 minus 3 is -2. That's right. So plug in -1. That's -1. Then -1 minus. That's -1 plus 3. So that's +2. Oh, I forgot my minus sign. That's what I did. Okay, so in here, you plug in 1, you get out -2. And then you got to subtract what happens when you plug in -1. And you should get out +2 when you do that. Okay, so that makes more sense. Because -1 to the third is -1. -1 plus 3 is 2. So it's the top one subtracted by the bottom one. Same thing over here. It's the top one. 2 to the third is 8. 8 minus 6 is 2. It's the top one subtracted by the bottom one. So if you plug in 1 in here, plug in the bottom one, 1 minus 3 is negative 2, so that's subtracted by a negative 2 in here. Okay, so now we got it. So this is 3, negative 3 times negative 1 is positive 3, so that makes 2. So I've got 2 minus a negative 2 here for area. And then this is negative 2 minus 2, that's negative 4. And then this is 2 minus a negative 2, so that's also 4. So I've got negative 2 minus negative 2 is 4 plus 4 plus 4. So we get 12.